if we talk about a unit vector, we can simply write that unit vector is a vector having unit magnitude and a specific direction. Any vector having magnitude equal to unit A is called a unit vector. Like say if we are having a vector A which is at an angle theta with the x-axis. So this vector A has a magnitude equal to A. So this vector A we can write as A angle theta. Now if we divide this vector by its own magnitude, then you can see what we are going to get. So if we divide A vector by A, so you will get A angle theta by A. This will cancel out this one, only angle theta. This is a vector which has a magnitude unity and having a particular direction theta. So this A vector by A is written as A cap, where this A cap is the unit vector in the direction of A vector. So in this direction, if there are n different vectors, then for all these vectors the unit vector can be written as A cap because it is having the same direction but magnitude equals to 1. And using unit vector we can also express vector as by this expression. If you carefully see this denominator A, if we take it on the left side, we can see that vector can be written as magnitude multiplied by unit vector. This is the representation of a vector in terms of its unit vector. Always remember that for any vector we can write it is its value, or a vector can be written as its magnitude multiplied by the unit vector in the direction. This itself is a very useful relation, that is expression or expressing a vector in terms of its unit vector. Now we define standard unit vectors in a coordinate system. We just talked about a general three-dimensional coordinate system having x-axis, y-axis and z-axis, which are mutually perpendicular to each other. What happens in vector analysis? Along x, y and z direction, standard unit vectors are defined. These are denoted by I cap, j cap and k cap respectively. In x direction, if we consider a vector which is of length 1 or length unity, this vector we denote as a standard by I cap. Similarly, in y direction, the vector of unit magnitude is written as j cap, and in z direction, the vector of unit magnitude is written as k cap. So we are having any vector which is parallel to x-axis and having say magnitude 3. This is a vector A which is having magnitude 3. We can simply write A vector is equals to 3 I cap, because the unit vector in the direction of x-axis is I cap and its magnitude is 3. So this vector of magnitude 3 can be written as I cap plus I cap plus I cap, or 3 I cap. When added one after another it becomes of magnitude 3. So it can be written as 3 I cap. Similarly, any vector in direction parallel to y-axis, say having a magnitude 2. So this B vector where B is equals to 2. This B vector can be directly written as 2j cap. The same thing exists in case of z direction also. If you are having a vector in the direction outward to the plane of this paper, so the C vector having magnitude 7, then C vector can be written as 7k cap. This is the way how we define a standard unit vectors I cap, j cap and k cap, and these are directly used to find out the vector notation or mathematical expression of vectors along x direction, y direction and z direction. Now we'll study how to express a position vector using standard unit vectors. We already studied that position vector is a vector which gives the position of a point. Say we talk about a two-dimensional coordinate system and say we are having a point which is having coordinate 5, 4, say this point P. Then position vector of this point with respect to origin can be given as RP vector. Now here this RP vector can be expressed in terms of standard unit vectors along x and y direction. For this we need to resolve this RP along x and y direction. Like if we consider the x component of this RP vector, this must be Rx, and this Rx vector will be of magnitude 5, and the y component of this will be Ry, which will be of magnitude 4. As along x direction we can simply state the unit vector is I cap, so this Rx vector we can write as 5I cap, and in y direction the unit vector is j cap, so we can state here Ry is equals to 4j cap. And in this triangle we can simply state the vector position vector of point P with respect to RP vector, or this OP vector can be written as this vector plus this vector. By triangle rule we can simply state RP vector is equals to 5I cap plus 4j cap. This is the way how we define a position vector using standard unit vectors. We are given with the angle theta which the position vector makes with the x-axis. So we can also use the length of these rectangular components as this Rx can be written as Rp cos theta, and Ry, which is opposite to the angle theta, can be written as Rp sin theta. And in this situation Rp vector can be written as Rp cos theta I cap plus Rp sin theta j cap. Similar analysis can be done in three-dimensional coordinate system also. Say we are having a coordinate system x, y and z, and we are having a point M which is having coordinate 3, 2, 7, and with respect to origin the position vector of this point M Rm can directly be written as 3I cap plus 2j cap plus 7k cap. So it is quite comfortable and becoming easy to express a position vector in terms of standard unit vectors. You just need to multiply the respective unit vector with the coordinate of a point to find out its unit, to find out its mean vector, its position vector. And we can also calculate the magnitude of this Rm by using root of 3 square plus 2 square plus 7 square. Easily you can also get the magnitude of any vector which is expressed in terms of standard unit vectors. Now we'll find out the position vector of one point with respect to some other point. Say in this coordinate system x, y and z, we are having a point P. Say for example its coordinates are 2, 4, 5. And so there is another point Q which is having coordinates 4, 1, 2. And we are required to find the position vector of point Q with respect to point P. So this position vector of Q with respect to point P, this we already studied. And we are required to find this RQP. Just to find this RQP, what we'll do, we first find out the position vector of point P with respect to origin. Say it is RP. Using its coordinate, we can directly write the position vector RP as 2I cap plus 4j cap plus 5k cap. Similarly, we can find out the position vector of point Q, RQ with respect to a reference point or origin. Again, RQ we can directly obtain by using its coordinate, that is 4I cap plus j cap plus 2k cap. Now if we just have a careful look on this triangle OPQ, we can see this OP vector, just after OP vector, we have placed vector PQ, that is RQP. So these two vectors are in succession. So we can simply state RP vector plus RQP vector. Here it is giving us the vector RQ. We just have a look on this triangle. By triangle rule, we can state that this RQ vector is opposite to the direction of RP plus RQP. So this RQ vector is the resultant vector of RP and RQP. So here we can simply write RQ vector is equals to RP vector plus RQP vector. By triangle rule we are writing. You can write in triangle OPQ. We are writing this. Now from here we can find out RQP. This can be directly given as RQ minus RP. This is a quite useful relation. You can say between any 2 points we are required to find their displacement vector or position vector of one point with respect to other. You can subtract the forward vector minus the backward vector. Say this position vector is of point Q with respect to P. So you can subtract the position vector of P from the position vector of Q to get the position vector of Q with respect to point P. Here we can simply subtract RQ minus RP. We just subtracted, you can see 4I cap minus 2I cap will be 2I cap and plus J cap minus 4I cap will be minus 3J cap and 2K cap minus 5K cap will be minus 3K cap. So this is the position vector of point Q with respect to point P. If you want to find out the magnitude of distance between P and Q, or which is RQP vector in magnitude, this can be given as root of 2 square plus 3 square plus 3 square. Here it will be root of 4 plus 9 plus 9, this is root 22. Be careful about such type of analysis, that is quite useful in future also.